And we are live. Okay, so since I'm recording this, the first thing I want to do is back up a little bit. So if you're at home and online, you need to copy this. This is called the sine wave, and it has this shape. We took the sine wave individual points from the unit circle using the y values because those are my sines. The period is the width. The width is 2 pi. The amplitude is the height. It goes up to 1, down to 1, okay? Cosine curve, same shape except for in a different spot. We took all the x values and we graphed all the x values along the graph, unit circle, and we got this. This is the cosine curve. It has a period of 2 pi, that's the width, and also has an amplitude of 1. Now what we want to do in our lesson is to change things, modify these. So on our first example, number 1, here's how I do these. The first thing I do is identify the curve. It's a sine. And so I know the sine curve looks like this. The sine curve, I like to say, is more like a roller coaster because you start here and you go up like a roller coaster, whereas the cosine is more like the water slide. You start at the top and you go down. Does that make sense, everybody? Okay, I do teach unconventionally. There's a reason I do that, so kids will remember. So then, I'm just going to, on the side, just draw the shape of one sine curve. It just helps me to put it down, okay? So I need this shape here. Okay, now let me put down then I know it's going to have an amplitude of 3. Okay, it's going to have an amplitude of 3. So I go 1, 2, 3. I got to put this in my graph. Okay, so I'm going to do that. I'm going to put my amplitude because I know the curve is going to go up to a height of 3 and down to negative 3. Okay, I need this shape. But I have what we call a frequency. This number here is my frequency. We call it B. We'll call it the letter B will represent this number. B is called my frequency. And frequency is like how many. Like that makes sense, like almost like an English term. What's the frequency? How many? Okay. So in this case, the frequency is 2. So I need 2 curves. So I need 2 curves. I need 2 curves. So I need 2 of these curves in this space. I need 2 curves. So it's going to be like this. It's going to be squished. I'm going to go 1, 2. I'll do it again. I need 2 curves. So it's going to be like this. 1, 2, right? So to do that, I'm going to look for my new period. The new period is always 2 pi divided by the frequency, okay? It's always 2 pi divided by the frequency. So in this case, it's 2 pi divided by 2, which makes sense. If I'm going to get 2 curves, I've got to go from one curve's got to go from 0 to pi. For me to get 2 curves in, I got to go from 0 to pi, and then another one from pi to 2 pi to get 2 curves in, because my new period is pi. So let me put down our angles, and the angles that are important for the unit circle are going to be the pi halves, the 3 pi halves, the 2 pi. So I'm going to put my angles down, and I like to go every 4 squares, and you'll see later on why I like to go every 4 squares. So I put my pi halves here, 1, 2, 3, 4, pi, 1, 2, 3 pi halves, 2 pi. Okay? So we're getting there. We're getting there, and I'll let you guys put the axes down while I check my phone. Okay, so let's take this shape and put it here. Does that make sense? And then we'll take this shape and also put it here so we get 2 of the curves. We're going to make it go from 3 to negative 3, so it's going to look like this. Now my important points, remember my 5 important points? It's going to start at 0. It's going to end at 0. Halfway through it's going to be at 0. A fourth of the way through it's going to be up at 3. 3/4 of the way down it's going to be down at negative 3. Okay? I like to do the dot to dot because then when I draw on the curve it's really pretty simple. Do the dot dot, draw on the curve, and there is 1 sine curve, but I need 2 because the frequency is 2, right? So I'll do this exact same shape again so I get 2 of the curves, okay? So I'm going to go here, 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 right? put in my 3 x-axes, and then I'll have my intercepts. I'll have my max, I'll have my min. I'll draw it in. Okay, there it is. And of course, it does keep going on and on and on. If we wanted to, we could keep it going, but there it is. There's 2 sine curves. There are 2 sine curves, height of 3, down to -3. Okay, how's that look? Not too bad? Thumbs up? Makes some sense? Okay, good. Carlos is with me. Okay, now if I look at number 2, it's very similar. It's very similar. But again, I like to start with just drawing down the cosine curve so I know the shape. Cosine curve looks like this. I'm just going to do a rough sketch of it. I know cosine curve looks something like this. Okay, that's one cosine curve. Of course, it keeps going and going and going, but if I have one of them, then I know what I'm putting. Okay, I know the amplitude is 4. So on my graph, I'm going to go to 4 and to -4. My frequency is 2. My frequency is 2. So I need 2 curves. I need 2 curves to fit between here. So that means my 2 curves have to be half as wide, or the new period would be 2 pi, always 2 pi, because that's the standard curve, divided by the frequency, which is 2, which gives me a new period of pi. So I'm going to take this shape and put it between 0 and pi. It'll have a height of 4 down to -4. Let's do it. So on my x-axis, I want to put down my angles. Pi halves, pi, 3 pi halves, 2 pi. Okay, I like to have those angles. The reason these are important is because this is all in terms of time. When you're talking about a cell phone or a sound wave or whatever, you need numbers that aren't degrees but numbers, right? And that's why we use radians, okay? So then I'm going to put this shape in, okay? So it starts up at 4 and it's going to end at 4. See what I'm doing? I put these 2 points, my important points, and then halfway through it's going to be down at -4. Oh, I missed that. I was off by 1. 1/4 the way it goes through at pi force. It goes through, and then at 3 pi force it comes back up and through, okay? And then I'm going to go ahead and just draw in my curve. So I'm going to get one of them. Make it try and look curvy because it really is a curve. It's not a pointy thing. And then there's one curve, and let's just repeat that pattern. Let's repeat that exact pattern again to get 2 curves. How's that? Not too bad. It's loud and high. Has a big amplitude and a short curve. Okay, you ready to turn the page? I'll wait for you. Give me thumbs up when you're ready to turn the page, okay? It's pretty cool. We're actually doing real math. I mean, I consider this real math. This is stuff people actually use. Okay, now we're going to have a shift. Now you remember the silly little dance. I know I just love to make a fool of myself, but you know, at least you won't forget, okay? All right, remember the stupid dance? Okay, so if it's inside the parentheses, it's going to be a horizontal shift, right? In the opposite direction. You think I'm going to the right, but I'm not. I'm going to the left. You think I'm going to the left, but I'm not. I'm going to the right. It's always the opposite direction. It's a horizontal shift. So we're going to shift this curve pi force forward, okay, to the right. That makes sense? So let's do that. So we have, in this case, we're going to have a horizontal shift. So we're going to shift pi force to the right. So what I'm going to do first, though, is just draw a regular sine curve in. So I'm going to do a regular sine curve from 3 to negative 3. Pi halves, pi, 3 pi halves, 2 pi. And again, those are the units on my unit circle. Those are the ones we want. So I'll take this sine curve, and I'm going to just draw it down, but an amplitude of 3, right? So again, just to make it easier for us, we know a general sine curve has this shape. It's always nice to see it because then, you know, you got it right in front of you. So we're going to put this down here between 3 and negative 3. So again, and I'm going to do it in pencil because I'm going to move this, okay? Starts at 0, ends at 0, halfway through we're at 0. At 1/4 of the way we're at a height of 3 because that's my amplitude. And 3/4 of the way we're down at negative 3 because that's my amplitude. Okay, so the curve should look like this. But I haven't moved it yet. Okay, this is my general sine curve. And you don't have to do it in 2 steps. Just for me, it's easier if I just do it in 2 steps. Okay? And now I'm going to shift it pi fourths. Well, if this is pi halves, then this 2 squares would have to be pi fourths, right? If 4 squares is pi halves, then 2 squares is pi fourths. Now you guys are seeing why I divide them up into squares, right? So I'm just going to take every single important point, I'm going to shift it, in a sense, to squares. Because 2 squares is pi fourths. All right, so this point at 0, 0 moves here, just over to the right. This point at the maximum just moves 2 squares over, which is pi fourths. This point at pi moves over pi fourths, 2 squares. This point at 3 pi halves, which is a minimum, moves over 2 squares, which puts me right there. And this point at 2 pi moves over pi fourths. And then I'll just connect my dots. Of course, it keeps going on and on, okay? Okay, we just did a shift. Same curve, same idea. It's just going to be a horizontal shift to pi fourths, okay? How am I doing? Am I doing okay? Not too bad. Okay, here comes the big one, but we can do it. We can do the big one. So the big one, we're going to do several things, okay? We're going to shift it pi 8 to the left, and then we're going to take it and we're going to go down 2. Before I do that, to make it easier on me, I'm going to just graph the cosine curve. I'm going to do this first. I'm just going to graph first y equals 5 cosine of 2x first, and then I'll move it. I do this in 2 steps. For me, it's just a lot easier, okay? So, cosine. General cosine curve looks like this. If I look at my notes, cosine curve looks like that. So it's going to be this shape. It's going to have an amplitude of 5, right? So I'm going to go up to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, negative 5. Okay, so I know the amplitude. Is equal to 5. I also have a frequency of 2, so I need 2 curves. I also have a frequency of 2, so I need 2 curves. That means I'm going to have to shorten up my curves. If I need 2 curves, I'm going to have to shorten up my curves. So I need a new period, so which is 2 pi divided by 2, so my new period is pi. Well, that makes sense. If I'm going to get 2 of them in there, I'm going to go from 0 to pi and then pi to 2 pi to get them in. So, all right, let me see if I can graph that in. So let's put in my pi halves, pi, 3 pi halves, 2 pi, okay? And then I'll take this shape right here, I'll put in my graph, okay? So it starts at a 5, it's going to end up at 5, right? Halfway through, it's going to be down at negative 5. fourth of the way through, goes through the x-axis, no, 3/4 of the way it goes through the x-axis. So here's the first curve. It's going to look something like this. And I'm going to repeat that pattern so I get 2 of them because it has a frequency of 2. So I'm going to repeat this pattern again because it has a frequency of 2. Okay, so it starts at 0, up at 5. It's going to end at 5. Halfway through, it's going to be down at -5. Fourth way through, it's going to be here and here. So I'll go ahead and put in my second curve. All right. Now I put it in pencil because the last thing I'm going to do is my shift. I'm going to do a shift to the left and a down. Okay, now here's why I like the 4 squares. I know right here is pi fourths, so 1 square has to be pi eighths. Does that make sense? If this is pi halves, that's pi fourths, that has to be pi eighths. So when I shift to the left, I'm really going to go 1 square, right? That's like 1 square. And then down 1. So every important point is going to move back 1, down 2. So this maximum here, am I going too fast? Give you a second to get caught up. So pi eighths is 1 square, right? According to my scaling. Okay, so watch. I'm going to go back pi eighths, down 2. This point moved to here. This x-intercept, back pi eighths, down 2. This point moved to here. This minimum, back pi eighths, down 2. The minimum moved to here. This x-intercept, back pi eighths, down 2, moved down to here. This maximum, back pi eighths, down 2, moved to here. This x-intercept, back pi eighths, down 2. This minimum, back pi eighths, down 2. This x-intercept went back pi eighths, down 2. This maximum went back pi eighths, down 2. And now all I'm going to do is connect my dots. You will not have anything this difficult on your test. Okay? When you get to pre-calculus, absolutely. But for right now, we just want to introduce it and look at it and see what it's all about. So 240, I think it is 240, 1 to 6 all. Let me double check. Ratios. Now, before you go, you can also do this stuff on Desmos, okay? And I do want to show you that, okay? Because it's handy to have Desmos. Okay. I'm sure it's 240. Yeah, so it's 240. It's these 6 graphs, okay? Now, worst case, you get really confused, okay? And I'm going to stop my recording. Wherever my thing is.